back to my channel. Today I will discuss in front of you first chapter of your NCERT book, which is physical world. So in this chapter, student, we will discuss about what is the meaning of science, and we will discuss about what is science and scientific methods, and also we'll discuss about physical science, what is physics, and after that the scope and excitement of physics, means in which we discuss about the domain of physics. There are two domains, macroscopic domain and microscopic domain, and in between them mesoscopic domain is also there. So after that we will discuss, after the discussion of these, we will discuss about the relation, means how the physics is related to the society and also the technology. So here I will start my video from first by the definition of science and what is the scientific methods and physical science and physics. So student, let's start the video here. See student, here I prepare a chart for you in which we will discuss these topic in this chapter or in this video. First here we will discuss the definition of science. So student, what is the meaning of science, or what is science? So see here, science is a type of knowledge which we gain through an experiment and an observation, when these two are organized systematically. Clear? So after that, after the definition of science, here what is the meaning of scientific method? If you want to gain any knowledge with the help of experiment, with the help of observation, so this knowledge you can take, this type of knowledge you can take, you organized your knowledge in systematic way. So this way or this method is called scientific method. So here we have 4 steps which we will follow when we want to gain any knowledge which is related to science. So these 4 steps are OPTM, means O for observation of fact, P for, after this, P for proposing theory or hypothesis to explain the observation, testing of validity of theoretical prediction. Next, M for modification of theory if necessary. So here student, I will explain this with the help of one example. You know that when we go from equator to pole, the value of G increases, and for that you know that initially we know that the size of earth is elliptical, and in this elliptical side, suppose here, basically for numerical we will consider the shape of size like a spherical of radius RE, which is near about 6400 kilometer. So here for that, observe, for that means for that knowledge, the value of G changes when we move from equator point to polar point in this place according to height. So for that we will see that here we will know, and for that you know that the radius of equator, means from the center of earth, the radius of equator is near about 21 kilometer more than radius of pole, means polar distance, equatorial distance is 21 kilometer more than polar distance. So that time you can use the point, you will use the formula GME by RE square. You can easily see that the value of g depends on radius of earth. So let's start the point from here. So we want to find the variation of g from equator to, when we move from equator to pole. So for that, first what we will do, we will take an observation. So for this type of observation, I handle a weighting machine with some weight my journey from this equator point to this polar point. And we will see that the value of g, for that the weight of the body is different in equator as compared to their polar position. So here we will measure the weight of that object in equator, which is supposed to be m into g or wm. And in different location, like this, 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 we will see the weight of the body, weight of the object which we held with the help of weighting machine is different in different locations. Clear, student? So these are our facts. And at pole their value is different. And similarly, again when we move from this position, their value is again different. So from this type of observation, when we took this type of observation, after that what we will do, we will make or give a hypothesis to explain this observation. So the hypothesis is that the value of g changes as we move from equator to pole and again pole to equator. Clear, student? So the observation, or you can say the hypothesis, is that the value of g changes when we move from equator to pole. And for that we need a testing of validity. Is I am saying correct or not? So for this validity, I will use here Newton's, with the help of Newton's gravitational formula, the relationship between small g and capital G, which is g is equals to gme by re square. Clear? So this is our testing. Similarly, we observe the value of g at pole. This is value of g at equator, and this is after that from, see here, student. So this is the value of g at equator, and now after this I will see here the value of g at pole, which is again gme by rp square. And we know that re, equator, is greater than rp. So by this we can say that re greater than rp. So we can say that because these two, it implies, listen student, gravitation means small g is inversely proportional to square of the radius of earth. You know that by this formula, gme by r square. So if re, as you know that radius of equator means equatorial distance is greater than polar distance, so that time you can say that ge is less than gp. Clear? So ge is less than gp. It implies gp is greater than ge. It implies when we move from e to p, equator to pole, the value of g increases, and at pole the value of g is greater, or you can say the greatest, as compared to equatorial point. So this is our testing of validity. If there is any supposed to be missing term is here, then we can use the modification. Here there is no modification. For that you can say that our testing of validity is correct. Modification is not a compulsory term. It is only useful if it is necessary. So I will write here some examples of physics or you can see that how the modification is necessary. So see here. So student, see here, I have written some example based on the modification of theory in physics. First example is that here, old concept, the shape of Earth was considered as flat, but after modification of this with the help of the variation of the value of g in different places is very small, means that the variation of g in different when it was found that the variation of g in Earth in different places is very small. So on the basis of this, the conclusion is that the surface of Earth is not just like a flat surface, it is considered as spherical shape. So after that, the next theory is geocentric theory. So according to geocentric theory, it is considered as the Earth is at the center of universe. So after the modification of this theory with the help of heliocentric theory, it was observed that the sun is stationary and the earth and the other planets are rotating around it or revolving around it. So the geocentric theory, you can say that, is replaced or modified by the heliocentric theory. After that, the modification with respect to the light, initially by Newton's theory, which is called corpuscular theory, is considered as light has a particle nature, and after that, some of the areas are satisfied by corpuscular theory. You will discuss this theory in your next classes. So here some of the areas was discovered by some of the areas was satisfied by this corpuscular theory, but in some of the reason this corpuscular theory in some of the reason this theory can't explain the nature of light. So after this, the nature of light is explained by wave theory given by Huygens, in which the light ray is traveled in the medium in the form of wavefront. So we will discuss the all things in your next classes. After this theory, Huygens theory or wave nature of light, the light is considered as quantum theory because of some limitation, because this theory has also some limitation as the corpuscular theory. So this theory is transformed or modified to the quantum theory, and light ray is considered as a quanta, and each quanta has an energy which is equal to h mu, and after this the nature of light is converted into, or you can say that modified into, from this quantum theory to dual nature of light, in which the light has two type of nature, which is particle nature as well as the wave nature, given by de Broglie theory. So this is the modification as time to time as they required to identify or to explain the nature of light and the phenomena which is related to light. So here, after that student, last one is that in advanced physics we know that if an object moving with some speed v and u, then their speed and their location, means that displacement and other acceleration is measured by Newton's equation. But if suppose the speed of particle or speed of body is equal to the speed of light, that time their speed will not calculate it, means that time if you want to measure the speed or you want to measure the calculation of the object or the body which is traveling in the medium with the speed of light, can't explain with the help of equation of motion. So in this case the equation of motion becomes fail, and we use the Einstein relativistic theory or Einstein theory here to explain this type of problems. So these are some examples in which you can see that why we need the modification of theory in physics. So after that I will explain here the definition of physical science and physics, and after that the scope and excitement of physics, in which we will discuss microscopic and macroscopic domains of physics. So here student, see I have written the definition of physical science and physics. Sciences which deals with non-living things is called physical sciences. The example of physical sciences is geology, geography, astronomy, astrology, physics, chemistry, and after this I have written here the definition of physics. You know that it is very common for you. Physics is a branch of sciences. Physics is a branch of science which deals with nature and natural phenomena. Example: reflection, refraction, scattering of light, twinkling of star, and other advanced sunrise, delay sunset, and similarly this type of other examples you can consider in physics. So after these two definitions, I will discuss here scope and excitement of physics. So here student I have written the scope and excitement in physics here. So there are two type of domains, but I have written here third one, which is mesoscopic domain, but main is two. So here student, when we discuss about the scope and excitement in physics, then we will study two type of domain. One is macroscopic. Basically we will study two type. There are three type of domains. So here one is macroscopic domain and second one is microscopic domain. So in macroscopic domain, it deals with the study of finite size. It deals with the study of finite size on terrestrial scale and an astronomical scale. So here the classical physics, as you can say that the classical physics comes under this type of domain, which is called macroscopic domain. So your familiar subjects under this classical physics are like mechanics, electrodynamics, thermodynamics, optics. So these all are topics or subjects which you will discuss under this macroscopic domain, or you can say that classical physics. So after that, you know that one is your favorite, optics, which you have already studied in your class 10th, lights reflection, diffraction, human eye. So these type of study will come in optics, and in case of mechanics we will study about the motion of any body with the help of motion of any body, and gravitation, change in gravity, and system of particles, and many more about the motion, and many more. So after that, the thermodynamics. After this, in thermodynamics we will study about the transfer of heat, measurement and temperature. Means that the topics which are related in thermodynamics are temperature related, or transfer of temperature, or heat engine. You will discuss in your second book. So this type of topic, entropy and black body radiation, entropy and other. So this type of topics will come in there. So in electrodynamics, student, we will study about the electric field and magnetic field, and in this electrodynamic study or electrodynamic subject, here the motion charge is in motion. So after the study of this macroscopic domain, we will focus here about the microscopic domain. In this domain we will study, or you can say that it deals with the atoms, molecules, nuclei, and other elementary particles. So under this domain, the modern physics comes. And this modern physics includes the study of elementary particles, atoms, molecules, and electrons also. So here, this type of topics or subjects we will study under the modern physics. Basically, when we discuss about the microscopic domain with the help of classical physics, means classical physics is not able to give a satisfactory conclusion to solve the problems related microscopic domain. So for that, we will use here the quantum theory, which is accepted nowadays or currently to explain the study of microscopic domain. And after that, after these two discussion, at last we'll see here the topic mesoscopic domain, which is an intermediate domain between the macroscopic and microscopic. So the main is these two topics of domain. Clear, student? So after that we will see about the next topic. So in next we will discuss here about the physics related to society and technology. As you know that in society we come, in society we come, and day by day you know that we want more and more advanced technology to do our work. Initially you can say that in starting we use lead line phones, which is, you can say that, wire communication, or you can say that wired communication. Nowadays we are using wireless communication in place of wired communication. So what is this? This is the advance or modification of our physics or technology. This is the modification or advancement in our technology with the help of physics. So here I have written some examples like that. So most of the developments which is done by physics in technology, in physics, have direct impact on society. So most of the development in technology gives direct impact on the society. Application of physics, which is called technology. So here the wire communication is updated into wireless communication. This is application of physics, which is called technology. More advancement in technology. Similarly, ground transportation. Initially you know that we use ground transportation to go one place to other place. But nowadays we have option: ground transport or air transport or water transport. So we have one more option, air transport, by which we can travel a large distance in short time. So this is what, this is also, you can say that, the modification or advancement in physics. So student, after the physics related to society, I will write here technology. So see, as I written here, technology is the application of principle of physics. It means that steam engine is a technology. It is based on the principle of thermodynamics. Rocket propulsion is a technology. It is based on Newton's third law. Sonar, sound, navigation and ranging is a technology based on reflection of ultrasonic waves. So these are the principle which I will write here. Steam engine, principle of, these are the principle of physics which is applicable on these type of technologies according to their need. So here in overall we can see that physics play an important role in our daily life requirements as well as the technology or society. So in this lecture you study about the physics what is the in this lecture you study about the scientific method and their steps. After that the scope, after that the physical science and the physics scope and excitement of physics, in which you study about the microscopic domain and macroscopic domain, and one more little between them which is called mesoscopic domain, and after that this one which is physics related to society and technology. So after this I will write here I will write here Indian physicists name and their contribution in physics. You will see. So I have written here name of the Indian physicist and their contribution in physics. First is J.C. Bose. Their contribution is discovery of ultra short radio waves, and C.V. Raman for inelastic scattering of light by molecules, and for M.N. Shah thermal isolation, then S.N. Bose for quantum statistics, then S. Chandrasekhar for structure and evolution of stars, and next Homi Jahangir Bhabha, means Bhabha Atomic Center, based on the name, cascades process of cosmic radiation. So these are our Indian contribution in physics. Thank you for watching this video, students.